In this video, I would like to introduce some common functions, look at their graphs, and also discuss their domain and range. All of these functions are functions that we want to be quite familiar with as we move forward in our pre-calculus class, and we will often be taking these functions and using them to create new functions through transformations. So first we have a constant function, y equals c for some number c. The graph of this function just looks like a horizontal line through the y value c. The domain of this line is from negative infinity to positive infinity. It is all real numbers. The range of this line is just one number, the number c. That's the only y value that is represented here. Next we have the identity function. The identity function is a linear one, y equals x. We can think of this as a line with slope 1 through the origin, through 0, 0. Every other linear function is some variation of this identity function. The domain and the range for the identity and for all linear functions are negative infinity to infinity. Third, we have the quadratic function, y equals x squared. The graph of this one looks like a parabola through the origin. It has a domain of negative infinity to positive infinity, and it has a range from 0 to infinity. I'm putting a bracket around the 0 here because it is included as a y value or output value on this function. Next we have the cubic function, y equals x cubed. This also passes through 0, 0, but it looks something like this. And we can see here that the domain and the range for this function will be from negative infinity to positive infinity. Now something interesting about all other power functions like x squared and x cubed that we introduced in the last two examples is that if the power is even, the graph will look like the graph of x squared. So for example, y equals x to the fourth is a very similar shape. It's just a steeper parabola than y equals x squared. This is the graph of y equals x to the fourth. And in similar fashion, the graph of y equals x to the fifth, that's an odd power, will be very similar to the graph of y equals x cubed. The graph of y equals x to the fifth might look something like this dashed line. So all the even power functions look like a parabola, all the odd power functions look like this S-curve. We go on to a reciprocal function. This is one of the most unique functions, and it is drawn in two different parts. It has a positive side and a negative side. Y equals 1 over x looks like this. This function never touches the x-axis or the y-axis. It just gets closer and closer to the x and y values of 0 as the graph goes out to infinity. So the domain and range of this graph are somewhat unique. The domain is from negative infinity to 0, 0 infinity, and the range is also from negative infinity to 0, union 0 infinity. Basically it jumps over the point 0 because the x and y values never equal 0. We have the absolute value function. This function always returns the distance that a number is from 0, so it always returns a positive value, and the graph looks like this. This has a domain of negative infinity to infinity and a range of 0 to infinity. Finally, we have some radical functions. The square root function looks like this, y equals the square root of x. It has a domain from 0 to infinity and a range from 0 to infinity. Notice the square root function is only defined for positive values or non-negative values of x. Finally, we have the cubed root function. The cubed root function looks similar to the square root function but continues in the negative direction as well. This is y equals the cubed root of x, and it has a domain and a range of all real numbers. Just like we spoke about for the power functions, the same pattern is true for the radical functions. If the root is an even root, like a square root or a fourth root, the graph will look like example number 7. If the root is an odd root, like a cubed root or a fifth root, the graph will look similar to example number 8. So there we have it, some of the most common functions that you will see in precalculus, and in a later video we'll talk about taking some of these functions and starting to shift them around and to manipulate them using transformations.